Okay, morning year 10. Welcome to a nice sunny day in the conservatory. And look at this rose. I agree with that. Anyway, so my aim here is to look at new topics each week from now. I'm going to do a big summary A3 sheet like this one. And I'm going to talk through some key points for about 5 or so minutes. Then your job is to go, okay, I understood that bit and that bit and that bit, but not that bit. So therefore I will look at the videos that Mr. Cross has suggested on the Go for Schools when he sets this as a task. Okay, so welcome to surds. Surds are where you have a square root of something. The what and the why, I'd always usually go through this, wouldn't I? So the what, they're square roots. So square root of 7, square root of 10, anything left like that is a surd. But why? What is the point? Why not just put it as a decimal? Well, the why is its accuracy. So if you left your answer was root 7 and you then used that in a further calculation, if you rounded it and didn't leave it in surd form, you'd end up with rounding errors, and that could lead to a world of pain. It's also used to break down big numbers. So by the end of this, I'll be able to give you surds like root of 300, and without a calculator, you'll be able to break it down into a much easier to work with surd. Okay, first, terminology. There's something called rational and irrational numbers. Rational numbers are not sensible, logical numbers. They're simply a number that can be written as a fraction, a over b. So 7 over 10, 0.3, because that could be written as a fraction, 3 over 10, minus 13, they can be negative numbers. 4 could be written as 4 over 1. Reoccurring decimals are also rational, because that 0.2 reoccurring could be written as 2/9. Irrational numbers are numbers that cannot be written as a fraction. Okay, so where a decimal doesn't reoccur. Good examples are root 2, root 3 and pi. They go on and on and on and on and on, and you cannot write them as a fraction. Also root 5, root 7, 11 and 13. So square root of any number, any prime number, cannot be further broken down surd-wise and is also an irrational number. Right, good. Now, rules. We have rules. It's good to have rules like stay 2 meters away from every surd. Here, these are the rules, and they're fairly simple. If you've got two numbers multiplied, a and b is the same as the multiplied within the square root, and divided same as divided in the square root. So some clever examples pre-done for you. So root 10 times root 2 would be root 20. Root 8 divided by root 2 would be root of 8 divided by 2, which is root of 4. Now, root of 4 is also actually 2. Now with surds and breaking them down, we're only looking at the positive square root. So normally we would say, that has two values, doesn't it? Plus and minus 2. But in this case, it's just 2. Okay, here you could do more than one surd all multiplied together. So you've got that going on, and that's going to give you root 42. And here you can have these divided. 10 divided by 2 is 5. You can also divide by a fraction, why not? 10 divided by a half, well, a half goes into 10, each whole number twice even, so 10 divided by a half is 20, so you end up with root 20. So that little section were the rules. Now, here's where we get the real use of surds, breaking surds down. Why do we need to use this? Why? Because thousands of years ago when I was a lad, imagine you're working on a Pythagoras problem. You got 4 and 8, you want the hypotenuse, square root of 80. You imagine trying to work out that puppy without a calculator. Would be very difficult. So what we do is we can break surds down to be able to break them down into smaller surds, so it's much easier to work out. So if I've got square root of 80, I can go backwards on my rules, and I can rewrite that as the square root of 16 times square root of 5, because 16 times 5 is 80. Now square root of 16, I think we all know, is 4. So actually square root of 16 times square root of 5 is 4 root 5. What really helps is having a special little list of square numbers down the side. and your tactic is to break down each surd into the highest square number. Okay, so root 80, highest one was 16. Root 32, highest one is 16 again, but 32 is 16 times 2. So we have root 16 times root of 2. Oh, try not to knock it all over, which is 4 root 2. Okay, root of 300, the highest square number that goes into 300 is actually 100. So root 300 is root 100 times root 3, which is just 10 root 3. And root 270, give this a go. What's the highest square number? Did you get 9? I hope so. So 9 times 30 is 270. So we've got square root of 9 is 3, so that's 3 root 30. Now root 30 is quite a large number, so we just double check. We quickly knock out the factor pairs. There are no squares in there, which is why there's a sad face. No. And so we can't break root 30 down any further. So to break it down, you choose the highest square number that goes into it. Look at all those lovely examples. I think my writing's got well neat. I've been practicing and everything. Okay, fourth, simplifying surds. So if I had this, treat it exactly you would as if it was like 2a times 5b or something. So you do 2 times 5, which is 10, and then you do root 3 times root 2, which is root 6. So you get 10 root 6. Similarly, this one, you would do 4 times 2 to get 8, and 8 times 2 to get root 16. Are you going to stop there? No, because root 16 is a square number and is actually 4. So it becomes 8 times 4, which is 32. My age, yay. I've got younger in isolation. And this one here is another beautiful example. You would just do 2 times 4 is 8, and 5 times 10 is 50. 8 root 50. Now, hang on. Are you going to leave it? Are you happy with your answer? You shouldn't be, because root 50 can be broken down into root 25 times root 2. Root 25 is 5, so that becomes 8 times 5 times root 2, which is 40 root 2. So always check your surd is broken down as far as it can be. Okay? You could do the same with divisions. Oh, smiley face randomly. My hair's grown as well in isolation. You could divide. Now remember what I always say in class, when you divide you can write them as a fraction. So I'm writing 8 root 24 divided by 2 root 3 as that. So 8 divided by 2 is 4. Root 24 divided by root 3 is root 8. Are you happy with root 8? You shouldn't be, because you can rewrite root 8 as root 4 times root 2. And root 4 is 2, so that becomes 2 to this bit here, pointy pen. This becomes 2, so 4 times 2 gives you 8. That's where the 8 comes from, 8 root 2. Okay, one more example. Again, writing that as a fraction, like this. 2 and the 4 we cancel into a half, and root 32 divided by root 8 is root 4. Make sure you get root 4 and rewrite it as 2, because square root of 4 is 2. Half times 2 is actually 1. What a lovely answer. Okay, let's tilt this stand up. The final bit is rationalising the denominator. Now, rational numbers are numbers that can be written as a fraction or a whole number. Okay, irrational are when it's a non-reoccurring decimal. So we want to write the denominator, the bottom number, as a rational number. Now, if I've got this, I can't really zoom in loads. Right. Okay, if I've got 1 over root 7, the denominator is root 7, which is an irrational number. What if I were to multiply the bottom by root 7? Clever. That would give me root 49, which is actually 7. But if I've multiplied the bottom by 7, I've got to do the same to the top. So doing the same to top and bottom, which is why I've circled it. Clever me. I get root 7 over root 49, which is root 7 over 7. So I've changed 1 over root 7 into root 7 over 7. They're the same value. Put them both into a calculator, I'll give you the same answer. And I've rationalised the denominator. 2 over root 5. Multiply top and bottom by? You got it right, root 5. Root 5 times root 5 is root 25, and on top we have 2 root 5, and that just becomes 5 on the bottom, because the square root of, where's the pen gone? Square root of 25 is 5. Now, these can get far more complicated, but we can do this. If I've got 1 over 2 root 2, before we've times the bottom by all of what is on the bottom and the bottom by all of what's on the bottom. Here we don't need to times top and bottom by 2 root 2, we just need to change that root 2 into a rational number. So times top and bottom by root 2, and you get root 2 on top and 2 root 4 on the bottom. Root 4 is actually 2, so we get 2 times 2, which is 4. Cool, huh? Bit more complicated here. The bottom is root 3. Just times top and bottom by root 3. And what you can also do with surds is expand brackets. So on the top there, we've got 1 plus root 3 times root 3, which we're rewriting as 1 plus root 3 times root 3. And your brackets will all stay exactly the same. Do root 3 times 1 and root 3 times root 3, okay? On the bottom is root 9, which is just 3. So once we've expanded our bracket, we get this, and root 9 on the right becomes 3. So we get root 3 plus 3 over 3, smiley face, and a yay! And the sun's out. And we've just done all of this in 11 minutes, 25 seconds. Right, I hope this makes sense. On Go for Schools, I'm going to set you a little bit of work and also some other videos to look at if none of this made sense and was all a complete blur. Stay safe and stay 2 meters away from surds. Bye!